The first topic for today is section 9.4, types of formulas, and there are three types of formulas I'm going to talk about. The first is a structural formula. I'll give you a chance here to pause the video and copy your notes. The second type of formula is a molecular formula, and again, I'll pause for a minute to give you a chance to copy your notes. And the third type is an empirical formula. So let me talk a minute about these. So structural formulas, if you follow along here, show the types of atoms involved, the exact composition of each molecule, and the arrangement of chemical bonds. So we see here the structural formula for water looks like this. We see it shows the structure, it shows the types of atoms, hydrogen and oxygen, and where the chemical bonds are. This type of formula gives us the most information about a molecule. However, they tend to be kind of big and take up a lot of room. For instance, acetic acid does. So if we want something simpler that takes up less room, we'll write it as a molecular formula. These show the types and numbers of atoms as they appear in the molecule. So we have the different types of atoms and the number of each, but it doesn't tell us anything about the structure. Acetic acid somewhat. That's why the two C's are separate and the H is separate, because this tells me that it is an organic acid with the Cu at the end. But otherwise, we don't have as much information as the structural formula, but the nice thing is it takes up less room. The third type of formula is an empirical formula. These tend to be formulas that we find through experimentation. And they tell what elements are present, and they give the simplest whole number ratio of atoms in a compound. Now, for something like water, the empirical formula is the same as the molecular formula because it's already as simple as it gets. Also, whenever we write our ionic formulas, they are always empirical formulas as well. However, covalent compounds like acetic acid, I rearranged that molecular formula so that all the carbons and hydrogens were together, and the oxygen can be written like this, but then we can reduce that because we can divide each of these numbers by 2 so that it's reduced to CH2O. And so CH2O is the empirical formula. The problem with writing acetic acid this way is that there are many covalent organic compounds that have this empirical formula. So it's a matter of which one would it be, because there are many of them. That's the difficulty with it. But there are some things that we can do with it that you'll see in an upcoming video.